Math 2414, Calculus 2, Calculus 1 Review, the Fundamental Theorem of Calculus Part 1, Correction. I thought about refilming the previous video, but I'm not going to, because A, I'm not getting paid to do this, so nobody's paying for a product with a mistake, and B, no matter how good you are in math, you will make mistakes. And it's a learning process. You learn from your mistakes and then you move forward and try not to make them again. But I wanted to leave the original video with its error to show you that it is okay to make mistakes as long as you catch them or somebody catches them and then you correct them and move forward. So if anybody was watching the previous video, either in my class or somebody else in the world of YouTube, and going, you made a mistake, I'm going to go get in the comments and blah, 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 blah. Well, first off, the description of the previous video says there is an error. And number two, I'm correcting it right now. So what was that error? That error was in the first part of the fundamental theorem of calculus that said if f of x is continuous on the closed interval a to b and g of x is equal to the integral from a to x of f of x dx, then the derivative of g is equal to f. So what's the error? The error is in the definition of g. In Calculus 3, I really beat this into my students' head because in Calculus 3 we're doing multiple integrals, double and triple integrals with 2 and 3 variables, and you have to be really careful to make sure that the differential involves a variable that is different from a variable in the limit of integration. In other words, you cannot integrate with respect to a variable, meaning that it's changing, and at the same time expect it to be a limit of integration. Bad, 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 bad. Never, 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 never have a variable in a limit of integration that matches the variable that you're integrating with respect to. So how do we fix that? Well, it's actually pretty easy. The name of the variable over here is completely irrelevant. All that's relevant is that we say what we're integrating with respect to, and typically it matches this variable, typically. So I can change this variable to anything that I want. The standard variable here is to use t, but the truth is, it really doesn't matter what you use as long as these match, and it's not that. So my apologies for writing something that was nonsense. It may not have looked nonsense. You may have gotten the gist of it, but I can't let that slide. This variable cannot match that one. And again, for those of you that are going to Calculus 2 and 3, well, you'll have double and triple integrals. You will have variables and limits of integration, but you got to make sure that they never match this guy.